is on the Thursday Slack channel. If you scroll up, is up, but I'm gonna put it here again. So so that's a recap from last week. We went through that. So when we loop through strings, like you see here, if this is not the one we did last week, but if you loop through string, you have to put a counter and go to the next to go through the indexes. Then we went through strings, so that's what we did last week. If you don't remember the lesson from last week, you can look at the chat from last week and the lesson is there. Also, so right now we're going to start with linear search. So finding items in a list. So which is what most of us do if we're going to deal with data, is finding data, specific data in a list. So the first one we did last week, it was to find 0 in a list. So we did a version. The version we did last week was a version that it was more similar to C, and that's why we did those. We had those terminal comments that people were asking me about last week about the exit. What is exit 0? What is exit 1? So exit I just was showing in Python, you can use those developer tools that you might carry from C, and the exit function. So exit 0 is considered when you put sys exit parenthesis 0, is a successful termination. It means that we can stop running, and exit 1 is nothing. The script has does not resolve the issue, so, or has not found the item, and that's why he has to repeat itself. So let me run this one on the CS50 like we ran last time. Numbers, I think it was numbers. The name of this was numbers, yeah. So I have it here. I'm gonna put it on the Slack so you can run it yourself. And I commented off so I can run 2 scripts at the same time. So I'm gonna put it on the Thursday class, and you can run it at the same time that I'm running it, because that's the best way to learn, is to do it, to practice and do it while I'm doing it. So while I'm doing it, you can try it and see. So the first thing I'm going to, I commented all this, so I'm going to comment it out. I'm going to comment this one. So that's going to be control \, and it's comment out. I'm going to save this, and then I'm going to comment this one out. So everybody knows what commenting means. When anybody is not sure what I'm doing. So when I put a pound in Python, it means that this line is off. So it's like you turn off that switch, it's not gonna run. So that's helped me to run only sections of the script, or do not run sections of the script. So it's called commenting. So I'm gonna run this one, which is what we did last week. So anybody knows what this script is gonna try to do. What is the function of this script that we have here? So we have a list. You can write it on Slack. You have a list, and has some digits inside. And exactly. So it's gonna see if the number 0 is part of that list. So we're gonna run it. So the way maybe, yeah, I have this bigger. So I'm gonna run it here, and you're gonna hopefully see. I'm already not typing right. Python numbers py, and then it says found. So that means that it found the number. If I change this to 9, what do you think is going to happen? Anybody's going to tell me what you think is going to happen? No found. Everybody agrees? I only see one person saying, so it's going to be no found. So this is what is called a sorting algorithm. So there are different kind of sorting algorithm, and a sorting algorithm puts element in a list in certain order. So what it is when this computer, the compiler is running, is comparing this number. We're gonna turn it to 0 here, 0. It's comparing the 0 with the first item on the list, this index 0, and it's saying, is this item 0? Is 0 in this index 1? And if it says yes, it's found. If it says no, then it goes to the next item, the index 1. And if it says no, it goes. So the compiler is gonna move through each item and compare it until it gets to the last one. So you can see here, 0 is in positions, is the last position. So it's index 1, 0, 1, 2, 3, 4, 5, 6. So it's gonna go to the index 6. So that's the way this is under the hood is running. It's comparing 0 with the first, then it moves to the next one, moves to the next one. So if you had a phone book with a lot of names, the way it's gonna work, this script, if it's a robot, it's gonna take a name, you can say John, and it's gonna look the first page, and then go to the next page, and go to the next page, and goes to the next page until it finds somebody called John. So that's called a linear search. And as you can see, this is a very short number of lists. So we finished finding 0 really fast. It didn't take that long. But imagine if this list, instead of having 7 items, will have thousands of items. So it'll take longer. So the way it's designed, the search is gonna take longer, and it's dependent on the number of items that are found that you have in the list. So any questions about that? No questions. So we go to the next one, and the next one is a version that is more Python-like. So the version up here is more C-like, but written in Python, and this is more Python, pure Python way of writing. What is the shortcut for command? Is control \. So I'm gonna write it here on Slack. You can do like I just did. You can select, and then you're gonna do, let me find it here, plus \, is to comment the whole selection. I have a Mac here, so if you have a Mac, it's a command instead of control. So this is a more Python. So the way it's written in Python, we don't use this. You can use it, and you may use it if you want to, but this is more a Python way of doing things. So we just say if, else. So it's gonna be a if else statement, and then the if you write it, it's very similar. You put the column, then it's print found, else it's gonna print not found. So we don't need, it's a more, the language is no better or worse, it's just the language, it works more Pythonic. So if we run it again, we say found, and then if you change this to 9, it's gonna work the same way. So this is a more Pythonic way to write it. So that's the takeaway from that. And this is a linear search. So a linear search is searching one page at a time, like in a phone book, or one item at a time. And the script's comparing each number on the list with 0. And if we talk about technical technical terms, uh, we use this notation here, which is called is a computational complexity, and evaluates how fast the sorting algorithms are. So these ones, the linear search is dependent on the number of items you're searching. So the more items, the longer it's gonna take. So you have 5 items, it's not a big deal. But if you have 5,000 items, that's where things get slowed down, and also it affects your memory, because the longer it takes, more memory you have to, because you have to save all those items so they can compare with each other. So this algorithm that's the notation. It's called O notation. So when you say linear search, use this notation here. And so that's one of the slowest sorting algorithms. So now we're gonna move into, I just put here what people were asking last week a lot about this. What is sys.x is 0? So I just put here, those are command lines that you can implement into Python. And remember, if you're gonna do this, you need to import the library of sys to be able to use those codes, that line of code. So now let's move to this one, but we did touch base last week about names. So now we're not gonna put numbers, we're gonna do names. So we're gonna put a list of names. So the same thing, this is 0, index 1, and so on. So let me open that one, and I'm gonna put the code on Slack, and please run it and let me know if you have any questions, because that's the best way to test if you're doing it right. And if you have any question, I can help you now if it doesn't work. So try to run this code and see what happens. So let's run this one. Python names py. So anybody knows, what is this code trying to do? Looking for run in the list. Exactly. And this one is also a linear search. So it's gonna compare, it's gonna go ask Bill, hey, Bill, are you Ron? And they said, no. And then it's gonna say, if Charlie, are you Ron? And no, and moving until the end. So that's a linear search. And we just use the if else statement. And now we can turn off line 5 and turn on line 6 and see what happened. So go ahead and run it and let me know what you get if you look for Ronald. Yeah, exactly. So since Ronald is not there, it's not gonna find it. So you can see how this can be applicable. If you have a long list of numbers, you can put it on a list, and then you can look for it and find data like that. So let's move on to the next one, the next example, and find dictionaries. So dictionaries are gonna be kind of like lists, but they're gonna have the curly braces. And dictionaries are used to store data values in key value pairs. So dictionaries will be more like what you are you will see on a spreadsheet where the key value is um, the the title of the column, and the values are going to be what you have inside the columns. So for example, here we have this dictionary called people. So Brian will be the key, and the value will be the phone number. And David will be anybody knows what David will be? Will be the key or the value? Yeah, exactly, the key. So Brian is the key, David is the key, and you have to put Brian in quotes because it's a string. And then how do you know which one is the value and which was the key? Because you have this column here. So what you have to the left is the key, and what you have to the right is the value. Also, in the future, you can put more items here, right? Like you can have a phone number, and you can have an address, and so on. So it's starting to look more like you will see on a spreadsheet. So dictionary are used to store data values. So you have to know the key, and then the number, the values, and you can have different values for the same key. A dictionary is a collection which is unordered, so you don't have to make sure it's ordered. Also, you can add items to the dictionary, and you can remove items from the dictionary, and you can allow duplicates also. And dictionaries have curly braces and have keys and value. So if we try to print this, anybody try to print this? So let me put it on here on Slack. Oh, this didn't print it quite good, this one. Oh, because I'm printing from here. That's why I need to go. If I print it from here to Slack, it works. Let me put it on Slack here. So, so what did you get? It prints both values. So yeah, so because you are printing the whole dictionary. So you are saying here, print the whole dictionary, and that's why the whole thing is gonna get printed. So let me see here. So if I print this one, the first one, line 5, I'm gonna get print the whole dictionary. What about line 6 here? If I print that, I use line 6, what am I gonna print? Yes, Brian's number. Very good. So you see how you can start being very specific about you start manipulating this data. So let's print this Python people 01. And I misspelled Python. Okay, so when you print, this is what somebody on Slack saw. So the first line here, you're gonna print, even the curly braces are gonna print because you're asking to print the whole dictionary or table. And when you use this bracket, notation here, where you're doing your indexing, you're getting only that value. So you're telling, I'm going to give you the key Brian and you give me the value. So that's why it says here the number. So you can start manipulating the data on the dictionary. So let's try this one. So this one is gonna ask for a name, and then it's gonna find that it's like similar to the one we have. So it's gonna ask us for a name, and we give them a name, and then it's like a phone book, like a contact list in your phone. We type a name, and then it's gonna tell us if the name is in the dictionary. So let me copy paste this. So any questions so far? So I'm gonna write Python people 02 y, and it's gonna ask me for a name. So where is that name come from? What line? What line is asking me for a user input? So anybody can see it. Where is the code that is asking me for the user input? Yeah, exactly. And remember, we have to get it. We have to get the library CS50 import get string in order to get the user input to use the string. So I'm going to put Brian, and I'm going to have to spell it the same way it's spelled and see what happened. So when I put Brian, it's going to give me the number, the phone number. So if I run it again and I put Anna, what do you think is going to happen? Yeah, so nothing's going to happen. Nothing's going to happen. So if you're a designer, you might want to put a message that says not found, or try again, or some other way to run it again. But on this one, it just asks us, it just says nothing, because Anna is not part of that. So this one, Anna is not in the dictionary. The other interesting things is happening here is on line 11. So if you look at line 11, you have a couple of things going on there. And this is what dictionaries are so useful, because you can start concatenating strings and getting information from the strings. So we do a formatted, we do this F to combine strings and non-strings, like all this notation. So we don't have to put quotes plus like traditionally. So this allows us, you put F at the beginning, and then you write everything in quotes, and then you can work with concatenating strings and non-strings together. So this number is what is showing up here on the terminal. So that's the output, the number that comes here. And then it's going to say curly braces, which is dictionary, go to the dictionary, called people, and then it's going to get the name. What is this name refers to? So it's bracket. So you know that it's going to look for something in the dictionary that is in that bracket, but it's not going to give me the key, it's going to give me something else. So the name refers to a variable. So what is the input is in line 9. Exactly. So the user input that we enter, which was Brian, is saved in the variable name, which is here. The variable name goes as the inside the bracket notation, and then we say look for the user input on their name, and it happens to be Brian. So it's gonna look here for Brian. And when it finds it, it's not gonna give me Brian, it's gonna give me the value. So do you understand? I just wanna make sure that that's when you give the bracket notation, you're not gonna get the key as an output, you're gonna get the value as an output. This one has, the key is Brian, and the value of the Brian key is this phone number. David is another key, and the value for the key called David is this value. And if we have more information, we can put here, add more. Next week, we're actually gonna add keys and values to a list. So we're gonna start with that empty file and we're gonna add to it. But here you can put Anna if it's not there, and Anna would be a key, and then we put here the value. And that would be a value. So you have different keys, and each key has a unique value. Does it make any sense? Okay, so if I now look for Anna, it's gonna show up, I hope. And then I give me the phone number for Anna. So try that and try to change things and see how it works for you. So this is what we talked about just now. So we use bracket notation to look in the index. So remember we talked about the indexes. So this is one, index 0, index 1. So when you put the name, Brian is gonna look for this one. So it becomes the index. So you can index go inside the dictionary and find specific information. The other thing is dictionaries are built in Python, and they are not linear. They're built in Python. What I mean is under the hood of Python, there is mechanism that make dictionaries be more efficient. And what is happening here is not a linear search. So this is what is called a constant time. So it's gonna take the same time no matter how big the data is. So this is a more efficient way, more efficient algorithm than the previous one that we have here. This one we had here, the linear search, because we are using dictionaries in Python. So the dictionaries have mechanism underneath the hood in Python that Python had created to make it more efficient. And it's called hash tables. And they are designed within Python and to be more efficient. And that's why they are constant time. So dictionaries and sets also are built with hash tables under the hood that make them more efficient than just doing a linear search. Yes, yes. So those are all great questions. And next week, we're going to be doing more with dictionaries that are going to be more complex. Yes, uh, you can actually create CSV file with dictionaries and start extracting data. So it's very versatile. So if you want to know more about uh, algorithm performance and how they work under the hood, and bubble sort and which ones are the faster algorithm, I have put here information in a video that explains very good how fast the algorithm work. So for now, this is a lot to process. So I will suggest you to run these examples and test them out with different values and run them. And you can also um, um, change the names, look for a name that is not in the dictionary, and test it out before next week when we're going to be doing more CSV files. So we're going to populate a CSV file, which is a data file that you can use in Excel with a dictionary. So anybody has any questions? The comma is required to separate between each item in the dictionary table. So that's a good question. So the way the dictionaries work, you have the key goes before the column. So there is a column here, those two dots. That's the key. Then you have the value, and then you have a comma, and then you have the other key. The other key and value, and so on. So you can write, but the main thing is that you're gonna have to the left of the, let me make this bigger. So to the left of the column, you're gonna have the key, and to the right, you're gonna have the value. And then you're gonna have comma, and then you're gonna put the other key and value pair. It's a key and value pair. So a key and value pair. So you're gonna have, all these are pairs. You can have, later on we can be more complex where we can add more values, but next week we're gonna see more complex. But for now, this is enough for today. But try to work it out. I can put more examples you want on a Slack that I can find so you can practice the dictionaries. And next week we're gonna work out a CSV file. If values are duplicated, they can be duplicated because that's what it tells you here. Dictionaries, dictionary collection, and does not allow duplicates. So it does not allow duplicates. So there are dictionaries and sets. So dictionaries, you can, you don't have to have an order. Also, you can remove it and you can add to it, but it does not allow duplicates because you have to have only one Brian. You can't have two Brians, you have to have one David. In sets, the sets are similar to the dictionary where you can store data, but sets you cannot change it. It can never change. So you cannot take data from it or add data in the dictionary, and also that's not allowed duplicate. If there are duplicates, are duplicate key with different value is displayed only the second instance? Well, let's try. Those are all great questions. So let's try to do that. So I'm gonna do that. So this is Anna, and I'm gonna change display only this with different values. So this is different values. See what happened. So it's only because what happened is it's uh, it's gonna run. That's a great question. So what happened is the script is going and find Anna, and it finds the first Anna, right? But it runs again, and this one overwrites the previous one. So here on the output, we only see this one because what happened, it went through it and then it wrote on top of the previous Anna. So that's why you see the last one. So that's a great point for being careful of having your data has to be correct, because if you have two different keys, you're only going to see the last value. So if I put another value here, so imagine you have 1,000 items and somebody just types the same key but a different value. So you're going to have an error on your data. Your data is going to get compromised. So if you run this, you're going to get the last one. So see, it got the last one because the compiler, the output is running it. So the script finds the first Anna, then finds the second and rewrites. It kind of erases the first output. You don't see it because it happened too fast, but it happens in the memory of the computer. So it spits out the first Anna, and then it runs and erases it and puts the next value, and then erases and puts the next value. So that's why when you create your data list, you have to be very careful of the integrity of your data, because then it's going to give you a false positive, a false negative. It's going to tell you the Anna has, there is only one Anna, and this is the phone number, when that is incorrect. So how do you fix that in the data? Anybody knows how to fix that in the data? If you have 3 Annas, but they are not the same person or they're not the same phone number, what would you do to make them so they get differentiated on the dictionary? Anybody knows? I see only one person on Slack, but if anybody else knows, you can unmute. Yeah, so you can make the key unique. So maybe this is the home number, this is the cell, and the other one, what would be? Well, the other one, we don't have to do anything because it's unique. So we can now run that one. Fax, yeah, that's pretty cool, fax, yeah, I like that. So we can, let's put here, this one is the fax and the last one is the cell. So I'm gonna find now the Anna fax and see what I get. So is it correct? Anybody checked it? If it's correct, do I get the fax number? Yeah, so that's how you have to do it. So to keep your data integrity. So any other questions? Those are great questions. I like those questions. I like to test it out because I can only think of what I think myself, but you guys challenge me to think other ways. So, so those are, so you can take it here. You can maybe, you know, we can change this. If you change to this, then it's gonna break. So if we change this variable here, well, let's put here, let's put a crazy thing. So let's put a key name and see what happens. So I'm gonna run it. What do you think is gonna happen? Yeah, it will give me a terrible error. So far it hasn't given me any error. So it's coming, right? It's gonna come. The error is gonna come after it asks me for the user input. So the error is, it doesn't give me an error, which is interesting because it doesn't mean that something is broken. Something is very broken because I didn't get an output, but the compiler doesn't recognize the error. So sometimes the compiler won't tell you there is an error in your code, but there is something broken because we didn't get an output. So so we have to look at here. So what's going on here? What happened here? What did I break? There is no Anna and didn't find the key name. Well, there is an Anna. Oh, I know what you mean. So let's run it again. So there is no Anna. That's a good point. There is only Anna fax and Anna cell. So let's put Anna fax and see what I get. Guess what? Yes, good point. Excellent. So now the compiler gives me an error. So this is something else. As a designer, you might want to write a line that if somebody types Anna and it's not there, it should say it's not found. So let's see if we can do that. So here, it was one of these. So we can put here else, and let's put it here and fix this because there is a design problem here because if you look for Anna, it's gonna tell you there is no Anna, but you don't know if you run it right or wrong. You might think there is something wrong because you know there is an Anna there. So let's make it more user-friendly. Let's run it. So I'm gonna put Anna and it says not found. So it's not found. And then one of the improvement will be maybe we can search for the only anything that looks like Anna. So I'm gonna write that for next week. How we can do like a wall search and search only the beginning of the key instead of the whole key. So we can we can customize that search because definitely this is a design problem. There is an Anna here. It's just because we didn't type the right name, we're not gonna find it. And it needs to be more flexible. So that will be an improvement. The other thing that's going on here is that when I look for Anna fax, it's giving me an error. I mean, this is not the error. No, let me run again. Okay. Then if I do anafax, which I know is there, it's gonna give me an error. So what is this error means? So it says, it has a lot of stuff, has to do with line 14. So something is here, line 14, and it says name key is not defined. So what does it mean that the name key is not defined? So it says name, key name is not defined. Well, in the computer language, it means that the computer doesn't know what key name is. So the computer have no clue what key name is. So the computer is going around, the compiler is going around the script, and it doesn't know what key name is because it doesn't have a value. We haven't defined it. So exactly, the only way we define here a variable called name, and we add the user add a value there. So we can take this and actually put a name like that without the user enter. We can do that. And then we put here this variable here. And we can run it now and it should find it. So this is giving me the fax number for Anna. But I already told them I want name to be the value of name. So I want anafax to be the value assigned to the variable name. And then here is gonna look for anafax because this is the value. The value of name is anafax, so it's gonna find it here. So when we do the user input, it's the same thing. So that's what it means. So that's how the two are connected. So if we do, let me write it the way it was written before. So this is to get user input. So you can save it like that. So now the user is, the compiler is gonna prompt the user for a name, and we're gonna give them a name, and then it's gonna be stored in the variable name, and then now this one has a value. And the other thing is you have to be careful. I think if I put extra spaces, it's not gonna find it. So if I run this and I made a mistake and I type 2 spaces, I put 2 spaces between Anna and fax, it's not gonna find it. Because spaces is also, we don't see it, but it's a string. So it's not an empty string, it exists. The space bar in your keyboard, actually when you click it, it creates a string that we don't see it, but it's there. So the computer knows that it's a space. So if I put 2 spaces with my space bar, it's gonna read it differently than 1. Okay, we have 5 more minutes. So I'm gonna stay on Slack or here. I'm gonna turn off my camera, but if you have any questions, stay around and I can answer your questions. So next time it'll be same time. We're gonna do CSV files. We're gonna work more on these dictionaries with CSV files. So if you have any questions, let me know and I'll try to find some examples, put it on a Slack. Also, I just was notified about this new class that is on more training that is offered It's a free class for a certification. So I put it here on more training so you all can read about it, and it's free, but you have to register before the 25th, and all the information is here. Okay, so you guys are being great. Have a great evening, and see you next week, or see you in Slack. Okay, bye-bye.